The German soldiers who faced American Sherman tanks in the fields and villages of Europe thought they understood their enemy very well. They believed the Sherman was a clumsy machine with thin armor and a gun that couldn't match their Panthers and Tigers. They thought they knew every weakness of this American tank. But there was one advantage they almost never saw and rarely even suspected. It was invisible, silent, and hidden deep inside the steel hull. It was the radio. Not just any radio, but one of the most advanced battlefield communication systems in the world at that time. While German troops measured tanks by armor thickness and gun size, American crews quietly fought a different kind of war. They fought with information, coordination, and speed, all made possible by a network of radios that turned individual Shermans into a flexible and highly responsive team. This is the story of how the American Sherman tank used its radios to change the way armored warfare was fought, and how many German soldiers never realized why the Shermans seemed to appear where they were least expected, or why American fire seemed to arrive so quickly and so precisely. Imagine a quiet French village in 1944. It's early morning. The cobblestone streets are empty, the doors and windows shut. In the distance, the dull roar of artillery rolls like thunder over the hills. A German infantry squad waits at the edge of the village, dug in among stone walls and hedgerows. Their officers have told them that tanks might be coming, but they don't know when or from where. Suddenly, they hear the clatter of tracks and the growl of engines. A Sherman tank appears at the end of the road. The German soldiers take aim with their anti-tank weapons, ready to spring the ambush. But before they can act, the Sherman stops, reverses, and disappears behind a barn. Moments later, artillery shells start falling not on the tank, but on the German position itself. The American crew never saw the Germans with their own eyes. They only caught a glimpse of movement, a reflection on glass, or the flash of a weapon. Inside the cramped interior of the Sherman, the tank commander pressed the microphone switch and calmly spoke a warning over the radio. Within minutes, unseen artillery batteries answered his call. The German soldiers who survived would later say that the American response was unbelievably fast. To them, it felt almost like the Americans had guessed their location or had spies watching. They didn't see the radio. They didn't hear the radio messages. They only saw the results. To understand why this mattered so much, we have to look at how tanks communicated before and during the early years of the war, and how the Sherman became more than just a vehicle carrying a gun. It became a moving node in a communication network. At the end of the First World War and in the years that followed, tanks were still a relatively new invention. Many countries built them, but almost no one fully understood how to use them as part of a fast-moving, coordinated force. Communication was a major problem. In the earliest tanks, there were no radios at all. Commanders used hand signals, flags, or even messengers running on foot or motorcycle between vehicles. On a noisy battlefield, in smoke, dust, and confusion, these methods were almost useless. Tanks easily became separated, lost, or delayed. A formation could turn into a scattered line of isolated vehicles in minutes. By the time the Second World War began, some armies had learned from these lessons more than others. The German army was one of the first to equip most of its tanks with radios as a standard feature. This gave their panzer divisions a huge advantage in the early campaigns in Poland and France. German commanders could coordinate maneuvers, change direction quickly, and exploit gaps in enemy lines far more effectively than their opponents. Radios were a key part of what the world would later call blitzkrieg. But early radios had their limitations. They were often based on older technology, used amplitude modulation, and were prone to static, interference, and unreliable reception. Communication worked, but it was far from perfect. Noise from engines and gunfire made it difficult to hear. Range could be inconsistent, and in bad weather or rough terrain, messages could become unclear or lost. Other armies, including the Americans, started the war behind in this area. Some early Allied tanks had poor or limited radio equipment or not enough sets for all vehicles. But the United States had a major advantage that would grow rapidly as the war went on. That advantage was its industrial base, its electronics industry, and its ability to produce and standardize advanced equipment on a massive scale. When the American M4 Sherman tank arrived in large numbers, it brought with it not only a gun and armor, but also a new generation of radios designed to solve many of the problems that had plagued earlier systems. From the outside, a Sherman tank looked like a large steel box with a turret on top. To the German soldier aiming a Panzerfaust or an anti-tank gun, it didn't look like a piece of high technology. But inside, hidden behind armored plates and metal boxes, was a communication system that was surprisingly sophisticated. American tank radios generally used frequency modulation instead of amplitude modulation. Without plunging into deep technical terms, the important point is that this made the radios much clearer and more resistant to static and interference. In simple words, it meant that American crews could hear each other better, even in the middle of battle, while engines roared and guns fired. Voices came through more cleanly and background noise was reduced. The radios were also designed to be part of a complete system inside the tank. The crew was connected by an intercom network. Each crew member had a headset and a microphone. The commander could talk to the driver, the gunner, and the loader without shouting. The driver could confirm orders, ask for clarification, or warn the commander of obstacles. The gunner could quickly report what he saw through his sight. This internal communication was already a huge advantage compared to tanks where the crew had to rely on shouting or tapping. But the real power came when these internal systems connected to the external radio network that linked tanks to other tanks, to infantry units, and to higher headquarters. A Sherman commander could switch between talking to his crew and talking to other tanks in his platoon. He could receive orders from his company commander, relay information, and coordinate movements. In some cases, tank radios could also connect directly or indirectly with artillery units and aircraft controllers. This meant that a single tank spotting enemy activity could trigger a chain of responses from far beyond its own guns. The radios were carefully standardized. Frequencies were organized and assigned to specific units and roles. American doctrine emphasized radio discipline. This meant messages were supposed to be clear, brief, and structured. It wasn't perfect in practice, especially under stress, but the structure helped the system function smoothly. The equipment itself was also produced in large numbers with consistent quality. Spare parts, training, and maintenance were easier to manage because many tanks used the same types of sets. This reliability was crucial. A radio that works every time becomes something crews trust and depend on. A radio that fails frequently becomes a dead weight. All of this combined to create something that was not visible to the enemy. There was no way for a German soldier to look at a Sherman and immediately see the clarity of its radio sets or the strength of its networks. This was an invisible edge. To truly understand the impact of these radios, we have to step inside the experience of the crew. Inside a Sherman, space was tight. Metal surfaces surrounded the soldiers. The smell of fuel, oil, sweat, and cordite filled the air. The engine made a constant deep growl. When the main gun fired, the entire vehicle shook. Yet in this environment, the crew could still hear the calm or urgent voice of the commander in their headsets. They didn't have to guess what the others were thinking. The loader knew when the gunner had a target. The driver knew whether to move forward, reverse, or hold position. The commander could constantly pass along updates, warnings, and instructions. Now imagine that multiplied by a whole platoon of tanks. 4 or 5 Shermans moved together, each with its own crew, all connected by radio. The platoon leader could direct them like pieces on a chessboard. If one tank saw a threat, it could warn the others instantly. If infantry reported an enemy position, the tanks could be called in to support them. If artillery fire was landing close, the tanks could adjust their movement or ask for fire to be shifted. When obstacles, mines, or ambushes were detected, the information did not stay locked inside a single vehicle. From a German perspective, this sometimes created a strange effect. They might ambush one Sherman and expect the others to blunder into the same trap. Instead, the remaining tanks would halt, find cover, and begin maneuvering in a coordinated way, often calling for supporting fire. To the Germans on the ground, it could feel like the Americans had some uncanny ability to react as a group, even when visibility was poor. The truth was simpler. They were talking to each other. One of the most difficult environments for tanks in Western Europe was the bocage country of Normandy. After the D-Day landings, American forces advanced inland into a landscape of small fields bordered by thick hedgerows and sunken lanes. Visibility was extremely limited. Tanks could be ambushed at very close range. German infantry and anti-tank weapons used the terrain to deadly effect. At first, American tank units suffered heavy losses. Shermans were knocked out in narrow lanes and at field corners where enemy troops could hide almost until the last moment. But as the campaign went on, the Americans adapted. They modified their tactics and even their equipment, adding improvised hedgerow cutters to the fronts of their tanks. Radios were an essential part of this process of adaptation. The bocage forced units to coordinate more carefully with infantry, engineers, and artillery. Tanks could no longer simply drive across open fields in neat lines. They had to move in short jumps, communicate danger zones, and time their movements with supporting fire. A Sherman platoon might advance one or two tanks at a time while others stayed back, watching and ready to fire at any enemy that appeared. Infantry could report enemy positions through their own radio nets, which could then be relayed to the tanks. When a strong point blocking a lane or crossroad was discovered, tanks could help mark it, and artillery could be called in to smash it before another direct assault was attempted. German defenders who had long experience in defensive fighting were often surprised by how rapidly American attacks could regroup after being thrown back. They would hit a tank or stop an advance in one lane, only to find artillery shells raining down on their positions minutes later, followed by a renewed attack from a different direction. For the Germans, it was easy to focus on what they could see. They saw the Shermans that burned or were abandoned in the fields and roads. They saw the crude-looking hedgerow cutters welded to the fronts of some tanks. They heard the engine roar and the crack of the gun. What they did not see was the flow of information that connected these tanks to each other and to the rest of the American army. German propaganda, and even many frontline soldiers, liked to think of the Sherman as an inferior tank. They mocked its high profile, its relatively thin armor, and its tendency to catch fire when hit, especially in earlier versions before ammunition storage was improved. They gave it nicknames suggesting it was easy to destroy. On a one-to-one basis, especially in open terrain and at long range, German heavy tanks often did have a clear advantage in gun and armor. A Panther or Tiger could engage and knock out a Sherman before the American crew even saw where the shot came from. Many German tank crews were highly skilled and experienced, and their weapons were deadly. Because of this, it was natural for German soldiers to measure tank quality by these visible and dramatic factors. They looked at armor thickness, gun penetration, and kill numbers. Radios were rarely spoken of with the same passion. In the early years of the war, German radios had indeed been a strong point of their armored forces. But as the war dragged on, production quality suffered, maintenance became harder, and the sheer strain of constant combat wore down both men and equipment. The Germans still had radios, of course, but shortages, repairs, and supply problems made reliable communication harder to maintain. Meanwhile, American industry kept delivering more and more radios, spare parts, and trained technicians. The American supply system pushed these out to the front in great quantities. For the Germans trying to read the quality of their enemy, this silent advantage was difficult to measure. Many German infantrymen fighting on the ground had no idea that the Shermans confronting them were part of such a dense communication network. They assumed that when one tank appeared, it was a local event, not part of a wider plan coordinated with artillery, air power, and neighboring units. Even German intelligence often underestimated the sophistication of American electronics. Captured equipment might be examined, but the full impact of how it functioned in a complete system was harder to appreciate. The battlefield was chaotic. Many Shermans that were knocked out burned so intensely that their internal equipment was destroyed, leaving little for investigators to study. In reports and memoirs, German veterans frequently commented on how quickly American artillery responded, how fast reserves appeared, or how sudden shifts in attack direction could be. They blamed spies, good aerial reconnaissance, or simple luck. Few fully grasped that much of this agility came from a simple fact. The Americans could talk to each other more clearly, more reliably, and in greater numbers. A Sherman tank was not only a gun platform. It was also a forward observer, a messenger, and a spotter. When a Sherman crew saw enemy movement, they did not always have to deal with it alone. If the target was too strong, or in a position where the tank risked being knocked out, the commander could use the radio to call for help. That help might come in the form of artillery fire, fighter bombers, or other units maneuvering to flank the enemy. This is what military thinkers call combined arms. It means using all the branches of the armed forces in a coordinated way so that each covers the weaknesses of the others. Tanks protect infantry from machine guns. Infantry protects tanks from close-range anti-tank weapons. Artillery and aircraft break up strong points and concentrations. All of this requires communication. The radios in Sherman tanks were one of the crucial tools that made this possible. They were the voice of the combined arms concept inside the armored units. A typical scenario might look like this. A Sherman platoon advancing along a road is halted by heavy fire from a village or a tree line. The commander quickly realizes that pushing forward would lead to disaster. He calls back on the radio, reports the situation, and gives coordinates or reference points. Higher headquarters receives this information and decides on a response. Artillery is called, maps are checked, and within a short time, a barrage is laid on the enemy position. After the shells land, the tanks and infantry move again. They probe forward, test the defenses, and if they run into another strong point, the cycle repeats. This process is far from perfect, and there were many failures and miscommunications. But the ability to even attempt such rapid coordination was built on the availability of reliable radios. For German soldiers on the receiving end, it often felt as if American artillery followed them wherever they went. They would pull back from one position only to be shelled in the next. Their machine gun nests that once held up entire attacks now found themselves bracketed by shell bursts within minutes. The Shermans they saw were the most visible part of this enemy machine, but the radios they carried were part of the reason that machine moves so efficiently. When historians compare tanks, they often list specifications: gun caliber, armor thickness, top speed, weight, production numbers. These are all important, but they do not tell the whole story. If you looked at a chart comparing a Sherman to a Panther or a Tiger, you might be tempted to say that the German tanks were clearly superior. Their guns had higher penetration at long range. Their frontal armor was thicker. Their silhouettes were lower in some cases. They looked more dangerous. What those charts rarely capture is the communication network that each tank plugged into. The Sherman cannot be fully understood simply as a piece of hardware. It must be seen as part of a larger system that included radios, logistics, doctrine, and the human training that tied it all together. When American forces advanced across France after the breakout from Normandy, their ability to keep moving, to exploit gaps, and to redirect units at short notice depended heavily on radios. Commanders could keep in touch with their units on the move. They could update orders without having to physically gather subordinates around a map in a fixed location. They could shift axes of attack as new opportunities or threats appeared. German commanders, especially later in the war, often found themselves trying to coordinate units that were scattered, understrength, and suffering from shortages of fuel and ammunition. Their communication lines were frequently disrupted by air attacks, artillery fire, and the general collapse of their infrastructure. Even when they still had skilled officers and powerful individual vehicles, their ability to control and coordinate those resources was slowly strangled. The Americans, in contrast, benefited from a robust network of radios at every level, from the smallest tank platoon to corps and army headquarters. The Sherman radios were a small but essential part of this greater pattern. With all the documents, memoirs, and technical reports we have today, it's easy to see just how advanced American tank radios were. But for the Germans living through the war, the picture was far from clear. So why didn't they fully grasp this threat? First, there's the simple reality of human focus under fire. Soldiers pay attention to what can kill them directly. A tank gun that blasts through a wall and vaporizes a position is impossible to ignore. A thick slab of armor that shrugs off repeated hits demands respect. A radio humming quietly inside the tank just doesn't leave the same dramatic impression. Second, their intelligence gathering was limited and fragmented. German analysts couldn't just pop over and examine every destroyed enemy tank in detail. Many battlefields had to be abandoned in a hurry. Others were bombed or shelled so heavily that the wrecks were barely recognizable. Even when they did recover radios, understanding their full significance required insight into how they were actually used in practice, not just a technical breakdown. Third, there was a degree of institutional bias and pride. German armored forces had started the war with a powerful belief in their own tactical skill and technological edge. Admitting that the enemy had surpassed them in a key area wasn't easy, especially when that advantage wasn't obvious at a glance. And finally, by the time American radio superiority might have been fully recognized and addressed, it was simply too late. German industry was under constant attack. Factories were bombed. Raw materials were scarce. Skilled workers were lost. Even if they could improve their designs on paper, putting them into production and getting them to the front in meaningful numbers was practically impossible. So the war moved on. More and more Shermans rolled across Europe, each carrying a radio system that quietly multiplied its effectiveness. German troops definitely noticed the effects, but they rarely understood the cause. They'd talk about the Americans being incredibly quick to react, good at calling down artillery, and always well supplied. Very few of them ever wrote about the radios inside the enemy tanks, but those radios were a huge part of the reason those impressions were so widely shared. Of course, technology alone doesn't win battles. A radio is only as useful as the crew that knows how to use it, trusts it, and follows the procedures that make it effective. And American tank crews were trained extensively. They learned not just how to drive, shoot, and maintain their vehicles, but also how to operate the communication equipment correctly. They learned voice procedures, call signs, and simple codes. They practiced passing reports and orders while on the move, drilling in using their radios under the immense stress of combat. Inside the Sherman, the commander practically lived with the radio. He was constantly listening to higher headquarters, to other tanks in his unit, and to his own crew. He had to filter information, avoid overload, and still keep enough mental space to observe the battlefield through his periscope or open hatch. This mental workload was incredibly demanding, but when it was done well, it turned the commander into the nerve center of his vehicle and his small unit. Over time, crews came to rely on their radios as a natural part of their work. Just like a driver trusted the engine to respond when he pressed the pedal, the crew trusted the radio to carry their words to others. This trust fostered initiative. If a crew knew they could call for help and be heard, they were more willing to push forward, to scout ahead, and to act boldly when opportunities arose. German crews, especially in the later years of the war, often lacked this same level of confidence. Equipment shortages, damaged radios, and chaotic unit structures meant that communication couldn't always be relied upon. A tank might find itself alone on the radio net, or connected only to a few nearby vehicles, with higher headquarters completely out of contact. This isolation only increased fear and reduced the willingness to take risks. In this way, the quality and availability of radios didn't just affect tactics. They shaped the very psychology of the soldiers who used them. When the war finally ended, militaries around the world studied what had worked and what had failed. Among the many lessons drawn from the conflict was the undeniable importance of reliable, clear, and widely distributed radios in armored vehicles and all other units. The Sherman itself would eventually be replaced by newer, more advanced tanks. But the core idea that every tank must be deeply integrated into a communication network would remain a fundamental principle. Radios would only become more sophisticated, adding encryption, data links, and integration with ever more complex command systems. For the Germans who had once led the way in tank radio use early in the war, the later years served as a harsh lesson in how quickly an advantage can be lost if it isn't constantly maintained and expanded. The American example demonstrated the incredible power of combining advanced technology with mass production and solid, comprehensive training. The story of the Sherman S radios is as dramatic as a tank duel between a Tiger and a Sherman on a foggy morning. You can't see radio waves slashing through the air. They don't leave smoking wrecks on the roadside. Yet for historians and enthusiasts who look closely, the communication equipment inside these tanks is one of the keys to understanding why American forces were able to fight the way they did and achieve the successes they did even when individual enemy tanks might have seemed superior on paper. When German soldiers faced Sherman tanks in the fields, forests, and towns of Europe, they judged them by what they could see. They saw a tall silhouette. They saw armor that their guns could penetrate under the right conditions. They saw tanks that sometimes burned when hit. But in most cases, they did not see the real strength hidden inside. That strength wasn't a thicker plate of steel or a larger cannon. It was a quiet voice in a headset, a clear message sent through the noise of war, a network of tanks, infantry, artillery, and aircraft all connected by radio. The Shermans didn't fight alone. They fought as part of a team, and their radios were the invisible threads that tied that team together. The Germans never fully realized how advanced these systems were, or how much they contributed to the flexibility and sheer speed of American operations. Today, when we look back at the war and debate which tank was best, it is easy to be drawn to the impressive lines of a Tiger or the sleek profile of a Panther. But if we want to understand why the Sherman, despite its flaws, played such a crucial role in the Allied victory, we have to look beyond armor and guns. We must look at the invisible advantage. The radios that turned a simple tank into a node in a vast web of firepower and information. The technology that German troops rarely saw, but which shaped the battles they fought, and, in many cases, the defeats they suffered. In the end, the Sherman wasn't just a machine of steel and fire, it was also a machine of communication. And that may have been its most important weapon of all. Thanks for watching, and if you enjoyed this series, be sure to like and subscribe for more deep dives into military history. See you next time.